Good evening, everyone.
Good evening.
Good evening.
Yes.
Okay. So today we are going on with balancing of chemical equations. Yesterday we learned about balancing of equations which are simple, but today we are going to look at moderately hard chemical equations. So the first equation we are going to look at is a reaction between phosphorus chloride and water to give us phosphoric acid and hydrochloric acid. Okay?
Yes.
So, to balance this equation, we are going to assign this side A, here we assign B, here C, and here we assign D. So, the first thing that we must always make sure is that the formula of the reactants and the products are correct. Are we together?
Yes.
So, the reactants and the products must be
Correct.
If they are not correct, then we may not be able to do what? To balance. So, when balancing, we try to make sure that the number of atoms of a particular element in the reactant side is the same as what? Number of atoms of the same element on the product side. So, if it is phosphorus on this side, it must be the same as phosphorus on the product side. So, let's look at phosphorus. So, we say phosphorus is A times 1, which is A. Okay, we add phosphorus, we equate to phosphorus in the product side, which is what? 3 times C, 1 times C, which is what? C. So A is equals to C, that is for phosphorus. We move to chlorine. Chlorine is 3 times A, which is going to be what? 3A, which is going to be equals to what? Chlorine in the product side.
1.
Chlorine 1 times D.
D.
So chlorine in the product side is D. Very good. We move to hydrogen. Hydrogen is 2 times B.
2B.
Which is what? 2B. Is equals to what? Hydrogen in the product side. 3 times C. 3C. Last is another hydrogen here.
1.
1 times D.
1.
1 times D.
D.
So we get here D. We have not balanced oxygen. Oxygen 1 times B is B. Is equals to oxygen in the product side 3 times C 3C. Very good. So we take these letters, we find a letter which is appearing most times, and then we give it a number. If you look at this equation, there is C, here we have C, and here also we have C. So C is appearing how many times? 1, 2, 3. So we can say, let C be 1. That is C. So since C is 1, then A is also 1. So C is equals to 1. A is equals to 1. We move to another side where we have C, so 3C. So B is equal to 3C, which is 3 times 1. That is going to be 3. Are we together?
Yes.
That is B. We have not got which one? We have not got D, because we have B and we have C. So we have not got what? D. So can we solve using what we already have? So you say what? 3C plus D is equals to 2B. So 3C, we don't have C, plus D. What is D? Where is D? We don't have D. Sorry, we have C. 3C, 3 times 1? 3. We add D. We don't know D. Is equals to what? 2B. 2 times 3? 6. Equals to 6. So D is going to be 6 minus 3. When you take 3 to the other side, you subtraction. So D is equals to what? 3. What have we not got? We have A, we have B, we have C, and we have D. So we now substitute these A, B, C, and D by use of what? The letters that we have here. So A is equals to 1. So we have this A, we write what? 1. Very good. B is equals to 3. So we have what? C, B, and we write what? 3. So we have written A, we have written B. C, what is the value of C? 1. So here, you write 1, you leave it the way it is, you because when you leave it the way it is, it means what?
1.
And then finally, we have D. D is equals to?
3.
So we have this D, and then we write 3. Now, can we confirm? Phosphorus? 1 times 1?
1.
Phosphorus in the product side? 1 times 1?
1.
Very good. Chlorine? 1 times 3.
3.
Chlorine in the product side? 3 times 1.
3.
Is also 3. Very good. We move to hydrogen. 2 times 3.
6.
Hydrogen in the product side? 3 times 1?
3.
We add 1 times 3. 3.
Which
3
is
plus 3?
6.
So they are the same. Oxygen? 3 times 1?
3.
3. Oxygen? 1 times 3.
3.
So that equation is
Balance.
You can pause now. Phosphorus 5 chloride and water to form phosphoric acid and hydrochloric acid. So in the same way, we are going to assign letters, which we are going to use to balance. So here is A, here is B, here is C, and here is D. So phosphorus 5 chloride will be balanced by A, water by B, phosphoric acid by C, and hydrochloric acid by D. In the same way, we say the number of atoms of a particular element in the reactant site must be equal to number of atoms of what? Of atoms of the same element in the product site. Very good. So let's start with phosphorus here. Phosphorus A times 1. A is equal to, let's look at phosphorus in the product side. C times P.
6.
C times 1, sorry. Is equals to C. So A is equals to C. Chlorine. A times 5. 5A. Very good. That is for chlorine. Is equals to chlorine in the product side. D times 1. Is equals to D. So 5A is equals to D. That is for chlorine. Let's move to hydrogen. 2 times B. 2B. Very good. Is equals to hydrogen in the product side. 3 times C. 3C. Plus what? Is another hydrogen here. 1 times D. Are we together?
Yes.
Equals to D. Very good. Finally, we have oxygen. B times 1. B. Very good. Is equals to what? Oxygen. 4 times C. 4C. Very good. Plus, in this other side, oxygen is not there. So it is B plus 4C. So we need to be clean enough. We check which one is appearing many times. We have B here, we have B here, we don't have here. We have C here, we have C here, and we have C here. So which one do we take?
C.
Because C, out of four equations, C is appearing 3 times. So the reason why we are doing that is so that it can assist us to balance easily. If we take another one, it may be difficult to balance. So we'll say C is equals to 1. When we say let C be 1. So C is equals to 1. So if C A is equals to C, then it means A is also equals to 1. Okay? We look for where there is also a C. B is equals to 4C. So B is equals to 4C. 4 times 1? 4. So B is equals to 4. Very good. Which one is remaining? We have B. We have A. We also have. Do you have A? So we have now. We can look for D. Is it? So D is equals to 5A. 5 times 1 is equals to 5. Are we together?
Yes.
That was D. Is that the last? A, B, C, D.
Yes.
All are present. So can we now substitute and see what will happen? A is equals to 1. So you write here 1. B is equals to 4. So here we write 4. We substitute. C is equals to 1. So here you either leave it that way or you write 1. That was C. And then D is equals to 5. So we write here 5. And that equation is balanced. We can just confirm that it is truly balanced. Let's start with phosphorus. 1 times 1, 1. Phosphorus here, 1 times 1, 1. Chlorine, 5 times 1, 5. Chlorine, 5 times 1, 5. Hydrogen, 4 times 2, 8. Hydrogen, 1 times 3, 3. And hydrogen, 5 times 1, 5. So 5 plus 3 is equal to 8, which is also the same as 8 on this other side. Oxygen, 4 times 1, 4. Oxygen, 1 times 4, 4. So that equation is also balanced. This is an equation of hydrolysis of aluminium chloride to form aluminium hydroxide and hydrochloric or hydrogen chloride gas. Okay, so in the same way, we write here A, balance using A, balance using B, balance using C, and the balance using D. Okay, so now we make sure the number of atoms in the reactant side equals to number of atoms in the product side for each particular element. Okay, so here we have aluminium. A times 1, A must be equal to aluminium in the product side. C times 1, C. So A is equal to C. Chlorine, 3 times A, 3A. Very good. Is equal to chlorine in the product side. D times 1 is equal to D. That was chlorine. 3 times A, 3A. And then chlorine there, D times 1, D. Okay? Yeah. We move to hydrogen. 2 times B, 2B. Equals to hydrogen in the product side, which is D times 1, is equals to D. And then finally oxygen, 1 times B, equals to what? Oxygen in the product side. 3 times 1 times this. 3 times 1, inakuja ngapi? 3. Okay? Yes. That was for what? Oxygen. There's one element I'm suspecting we may not have balanced well. That is hydrogen. 2 times B, 2B, plus hydrogen, 3 times 1, 3, plus C, 3C. So here it was supposed to be 3C plus hydrogen here, 1 times D. Like that. So again, let's look for a letter that is appearing in many of the equations. So we have B here, B here, C here, C here, C here. So which one is appearing many times? C. So we'll say let C be 1. Okay? Yes. Let C be 1. So if C is equal to 1, then what is A? A is also equal to 1. Are we together? Yes. And C is equal to C, and C is 1. So B is equal to 1. So A is equal to 1, B is equal to 1, C is equal to 1. What are we remaining with? D. Now what is D? So we have D plus 3C is equal to 2D. So what is D? D is equal to 2D. We take 3C to the other side. So less 3C. So D is equal to 2B. 2 times B, that is 2 times 1. 2. Less 3C. 3 times 1? 3. 3 times 1? 3. Is there a problem? It's equal to 3. Is it? So D is equal to negative 1. Can you stop up? An equation of hydrolysis of aluminium chloride using water. What do you call? Aluminium hydroxide and hydrogen chloride gas. So we look at the number of hydrogen atoms. A times 1 is equal to A. And then aluminium on the other side. C times 1, C. Okay? In sub to chlorine. 3 times A, 3A is equals to chlorine in the product side. So 1 times D, D. Then we move to hydrogen. 2 times B, D. Hydrogen, 2B. Is that okay?
Yes.
B times B is 2B, 2B. We come to hydrogen here. 3 times C, 3C. We add a hydrogen in hydrogen chloride. 1 times B is D. Then finally we deal with oxygen. Oxygen is B times 1. B is equals to oxygen 3 times 1 times C.
3C.
3C. That is this. So oxygen, the reactant side is B, the product side is 3C. 3C. So when we reach this position, we look at the letter that is appearing in most of the equations. So this is equation 1, this is equation 2, this is equation 3, and this is equation 4. We have these 4 equations. Now we look for a letter that is appearing many times. And we have seen the letter is letter C. So you say let C be 1. So it means C is equal to 1. So A is equal to C. So it means what? A is equal to 1. Are we together?
Yes.
Then we have B. B is equal to 3C. B is equal to 3C. So what is 3C? 3 times 1? 3. Very good. Then we move to D. D is equal to 3A. What is A? 1. D is equal to 3 times 1. It's going to be 3. And then finally, that was the last one.
Yes.
Let us now substitute and see if it is working. A is equal to 1. So what do? You can wrap it and leave it like that, or you can write 1 here. Okay? B is equal to 3. So you wrap this B and you write 3. Is that okay?
Yes.
Now we move to C. C is equal to what? 1. So we wrap this C and we write what? 1. And then we move to D. D is equal to 3. Very good. So here D is equal to 3. So we write here 3. Let's confirm that it is truly working. Aluminium 1 times 1. 1. Aluminium 1 times 1. 1. Chlorine 1 times 3. 3. Chlorine 3 times 1. 3. So number of chlorine atoms are the same?
The same.
On the reactants and the products side. 3 times 2 for hydrogen 6. Hydrogen 1 times 3. 3 plus 3 times 1. 3. 3 plus 3? 6. That is hydrogen. And lastly, oxygen 3 times 1? 3. Okay? And here 3 times 1? 3. That is all the oxygen. So oxygen, both in the reactants and the products are the same?
The same.
Are the same. So that equation is well balanced.
Balance.
So the key things in balancing of chemical equations, you must make sure the formula of the reactants and the formula of the products are correct. The formulas must be correct. If the formulas are not correct, then it means you are not going to be able to balance the
Equation.
That is if the formulas are not correct. Number 2, you must make sure that the reactants and the products are also correct. Like for example, if somebody writes aluminum chloride plus water, you form what? Aluminum hydroxide, and you forget to write hydrogen chloride, that equation will never be balanced. So the reactants and the products must be correct. The formulas must be correct. Reaction here, neutralization of lead 4 oxide to form what? By nitric 5 acid to form lead, nitrogen, and water. A neutralization reaction. A reaction whereby we are having what? A salt and water as the only products. So let us use the same letters again. This is going to be A, this is B, this is C, and this is D. Are we together?
Yes.
A, B, C, D. In balancing, make sure number of atoms of each element on the reactant side equals to number of atoms on the product side. That's why we are equating these letters. The reason why we are equating letters is because number of atoms are supposed to be the same on the reactant side and on the product side. Very good. So let's start with the lead. A times what? A is equals to lead. C times what? C. Let's go to oxygen. A times what? A. Plus, there's another oxygen here. 3 times B. 3B. Is equals to oxygen on the product side. 3 times 2 times C. 6C. We add oxygen there. D times 1. D. Okay? We are done with what? Oxygen. We are remaining with hydrogen. B times 1. B is equals to hydrogen in the product side. 2 times D. 2D. That was hydrogen. We are now remaining with nitrogen. B times 1. B is equals to what? Nitrogen on the product side. 2 times 1 times C. 2 times 1 is 2. Times C, 2C. Let's follow the same formula or the same working. Let's look at a letter that is appearing many times. C, 1, 2, 3. Okay? B, 1, 2, 3. Is appearing in many, how many questions? 3 questions. A, 1, 2. So you cannot take A. C, 1, 2, 3. D, 1, 1 only. 1, 2. Only 2. Isn't it? So now, we either take C or we take B. So let us take B this time around. So we say, let B be 1. Let B be 1. So B is equals to 1. Are we together? Now B is equals to what? 2D. So what does that tell us about D? D, if B, which is 1, is equals to 2D.
3.
What about D alone?
1.
D is equals to 2D. D is equals to 1. 1 is equals to 2. 2D. What about D alone? You divide by 2, you divide by 2. This one and this one will go. Are we together?
Yes.
So it means D is equals to a half. Is that okay?
Yes.
So we are done with these equations. And then we go to C. B is equals to 2C. So what is C? C is equals to? B is equals to 2C. B is equals to 2C. So C is equals to what? 2C is equals to 1. Because B is equals to what? 1. So divide by 2. We divide by 2. So C is equals to a half. Is that okay?
Yes.
Good. We are done with B, C, D. What's remaining? A. A is equals to C. A is equals to a half because C is a half. Now from what we have here, we are having fractions. We have 1, we have a half, we have a half, and we have a half. Now how do we remove this? We multiply all sides by the numerator. Are we together?
Yes.
This is a half, so you remove this a half by multiplying all sides by 2? By 2. So this is B is going to be times 2. Okay, so B is going to be 2. And then D times 2 is going to be 1. C times 2 is going to be 1. And then A times 2 is going to be 1. So we have A is equals to 1, B is equals to 2, C is equals to 1, and D is equals to 1. So let us now substitute in our equation. So here A, what do you write? We write 1. Okay, that is A. B is 2. So we write here 2. C is 1. So we write here 1. D is 1. So we write again here 1. Let us check if it is balanced. Lead 1 times B. 1 times B.
1.
1. Lead 1 times 1.
1.
1 times 1. 1. Very good. So lead 1 times 1. 1. 1 times 1. 1. Oxygen 1 times 1. 1. Plus 2 times 3. 6. 6 plus 1. 7. Let's go to the product side. Oxygen. 3 times 2 times 1. 3 times 2? 6. Times 1? 6. R 1 times 1? 7. So oxygen 7. Hydrogen 2 times 1? 2. Hydrogen 1 times 2? 2. And then finally, nitrogen. 2 times 1? 2. Nitrogen. 2 times 1? 2. Times 1 again? 2. It is balanced. 2, 2. On the reactants and the products are same. This other equation here, a reaction between magnesium oxide and sulfuric acid to form magnesium sulfate and water. This is neutralization of magnesium. Neutralization reaction. Are we together?
Yes.
A neutralization reaction. Now, in the same way, A, B, C, D. A, B, C, D. Okay? Let's start with magnesium. A times 1, A is equals to magnesium in the product side. C times 1, C. Oxygen. A times 1, A. Oxygen. 4 times C. Sorry, oxygen in the reaction side we have not considered all. It was in magnesium oxide. A times 1, A. And then here, B times 4, which is 4B. So it is A plus 4B is equals to oxygen in the product side. C times 4, 4C. R, D times 1, which is going to be D. Are you seeing that?
Yes.
That is now for oxygen. We move to hydrogen. 2 times B, 2B. We are, sorry, there's no addition. Hydrogen is only 1. And then in the product side, D times 2, D2D. That was hydrogen. We move to sulfur. B times 1, B. Okay, and then sulfur in the product side. C times 1, C. Okay, that was sulfur. And you have got for magnesium, oxygen, hydrogen. And so all of them have been obtained. Let us check which one is appearing many times. B, B, B. B is appearing 3 times. C, 3 times. D, 1, 2. So we can consider B.
Yes.
So we say let B be what? B1. Okay? So B is equals to 1. C is equals to 1. So 2B is equals to 2D. So 2B, so 2 times 1, which is 2, is equals to 2D. Like that. So you divide by 2, you divide by 2. So D is equals to what? 1. So D is equals to 1. We are remaining with only one, that is A. And A is equals to C. And C is equals to 1. So A is equals to 1. So we are done. We now substitute. This is going to be A, which is 1. This is going to be B, which is also 1. Okay, 1, 1. C, which is also 1. And then D, which is also 1. Meaning, this equation was self-balanced. Let's do that.